Hello, everybody. I'm Nelson.
This is Zhuang.
Han-Wei.
I'm Yutong.
I'm Han-Wei Chen.
And we're presenting you car monitoring system. We call our product DTMC, Don't Touch My Car. So our product consists of 3 different modules. The first module plugs into the OBD port of the car, which is just a port that's down by the gas pedal. What this module is going to do is detect particular undesired events to your car that is being unattended in a parking lot. Once one of these undesired events is detected, you'll get a message on your phone telling you which of these undesired events is suspected of taking place. A 360-degree picture will be taken from a second module within the car. The second module will be either mounted on the dashboard or on the windshield of your vehicle. This 360-degree picture will be sent to the user's phone, and the user can also extract more information from this picture on an Android app that's on their phone. Here's a little flow chart of the events that take place. First, an event is detected. We then send a character to the Raspberry Pi indicating that we should record a video or take a picture. This picture or video is sent back to the microcontroller. From the microcontroller, it is sent to the user's phone via a multimedia message, and then we can do further image processing on the Android app. So I was responsible for the accelerometer, which is what's used to detect particular events, and we use the MMA 8451, which is actually a tri-axis accelerometer, which was on our development board from Freescale. We use the accelerometer in plus or minus 2G mode, which means that it can detect acceleration up to 2G units, 2 units of gravity. We read the samples at 500 hertz, or every 2 milliseconds, and we did encounter some sensitivity issues. Events such as leaning on the car or a child moving in the back seat, which were 2 of the desired events that we wanted to indicate to the user. Since cars have dampeners and shocks, the acceleration felt by the accelerometer on board was too small to pick up. So the events that we did detect were someone opening your car door up, like onto your car, or a hit and run while parking. And since nobody volunteered to have a car door opened up on their car, we had to use some pseudo events. So to imitate a car door hitting your car, we simply closed the car door aggressively. And as for a hit and run while parking, we just rocked the car back and forth. From the samples that I read at those every 2 milliseconds, I put them into a Matlab function, which created these 6 plots. On the left, you have the values with the absolute value taken. And the reason we take the absolute value is because events that occur on opposite sides of the car have the same magnitude but opposite sign. So by taking the absolute value, the side of the car is irrelevant. And on the right side, we have it both normalized and absolute value. And by normalized, I mean we just take an initial value and we subtract all that value from all the following values. And what that does is it eliminates the need for the car to be on a level surface. And we would just look at these plots and find patterns and create the algorithms off these patterns.
All right. I'm taking charge of the internal communication. Basically, in this project, it's between the microcontroller and the Raspberry Pi. And we are using the Bluetooth. We installed a Bluetooth dongle on the Raspberry Pi side, and we're using an RN42 module on the microcontroller side. And we use the dongle to be the host to start the connection. And the Bluetooth connection will be set up automatically when the Raspberry Pi powers up. So that's like the user doesn't need to do anything, just plug in the Raspberry Pi and it gets to work. When an event is triggered on microcontroller, it will send a signal to Raspberry Pi, and the Pi will take a picture and send it back to the microcontroller. Before sending the picture back, it will first send the picture size and send the phone number of the user to the microcontroller so that it knows like how big the picture is and who to send it to. Because of the limitation of transmitting data on the size, the picture won't be sent like once. It will be converted into an array of characters, and we'll split the characters into packages, basically like 50 bytes of character, one package. And then the Pi will send the picture to the microcontroller package by package.
Now I will introduce the GPRS part. It is our main tool for the external communication. We choose the SIM900 to send a multimedia message because it has a good performance in sending this one. And the multimedia message we send including two parts. One is the one-line text, which will indicates what kind of the event we have has been detected by our system, and another picture is 360-degree paramonic, and sent by the take by the Raspberry Pi and then set it over the Bluetooth to the microcontroller, and then send it to the GPRS in packages, and then send to the user's phone. And the pictures, we can also have a better view in our Android app to have a DWAP, and then we will talk that more later in the image processing part. In addition, the user could also change their phone number via the SD card, which insert into the Raspberry Pi, and the Raspberry Pi gonna send that phone to the GPRS directly.
Okay, so one of the requirements is to show what's going on inside the car, either with a picture or with a video. But since we are using a panoramic lens, so with the image being bended into a circular image, it's hard for the user to tell. So for that, we have to develop an image processing program, and the main task is to dewarp the 360 image back into 2D image, so it'll be easy for the user to view. And we use OpenCV library to accomplish such task, which this task is performed on our Android app, which is an app the user can download directly from the Google Play Store. And the output image will be stored on the user's phone device. And we are unable to get the video processing on the Android app because Android OpenCV lacks some key feature we need to develop the video processing, but the remaining video will be stored on Raspberry Pi. So here I got two sample image I can show you. So the image on the right is the image that was initially taken with Raspberry Pi, and as you can see, we got a lot of stuff going on here, and everything is bent into the circular image. So through the Android app, the user is able to dewarp the central donut part and retain the 2D image.
Actually, I'm doing the PCB part. The PCB, the printed circuit board. The board is in 3 times 2.5 inches size. On the PCB module, we will have a microcontroller to process all the requests from other chips, and we have RM42 at the Bluetooth chip to do the internal communication. We have MMA8451 to the accelerometer to detect events, and we have the SIM908C at the GPRS module to do the external communication. And also the board will be powered through a OBD2 connector, which can be connected to the car to get the power. But we never get the GPRS to work at the SIM908C module. So right now we are not demoing our project with the board. And
So this is just going to show an example of the event detection in the car. The first LED will be just a green one with the system turning on. And the video is not working, so it's a blurred picture.
How do I click on from here? Okay, maybe.
So the first video we're going to show you is just simply, it's going to have dual videos. One's going to be of the development board that's plugged into the OBD. And a little window's going to pop up of me outside the car, either aggressively close the door or back and forth. Green light just means that the system's activated. Red light means the door's closed, and blue light is the door's locked.
avoiding the warning.
And since we weren't able to get the car onto the 9th floor, we have a second video which is meant to detect table events just by either pushing on the table or pressing its table or pushing the board. And we'll show you this clip, and it also shows the process of taking the picture on the Raspberry Pi, sending the bytes, as well as receiving it on the user's phone.
Okay.
Not a question yet.
secondary cloud here. I'm sorry, I have to play from here.
It's worth it.
So I'm sorry, it's not working here. I'll have to go to the Dropbox real quick to play the video, if that's fine with you.
So, well, experience that, can I get some questions? So
Yeah, sure.
How long video do you guys store?
Well, we're able to store 30 seconds on the actual Raspberry Pi, but right now that video just stays on the SD card.
Okay. Is that 30 seconds after the event is detected, or is there some
Wow.
time and some time after?
Well, as soon as the event is detected, within milliseconds, it sends a character for
But
an initial.
wouldn't it be nice to actually have video evidence of the car actually hitting?
It would, but we'd have to do a public feature to do that.
Well, you can record and then just keep a buffer there.
I guess we could, but I guess our hardware doesn't really support something like that.
Okay.
So you'll see that the LED changes color, which is available. And then you see the Raspberry Pi will take a video, and then you'll start to see a bunch of characters go across the screen. That's just it sending the bytes. We're just outputting that. There's no need to output that, just for display purposes. And
Oh, actually, it's not that quick to resend that.
yeah,
message.
it's like about 2 or 3 minutes process to actually receive the text message. Yeah. And then from there, you can open up the Android app. From the Android app, you can select any photo from your gallery to dework it. Any more questions? Thank you.
On the Raspberry Pi?
We were able to dework on the Raspberry Pi.
So the
But-
thing is, Android, the Raspberry Pi does not have a graphic card, so you eventually take like 5 minutes to develop a 5-second video, whereas on the desktop, on the Video Studio, it usually take like 2 to 3 seconds to compile the stuff. But we were trying to get it on the Android app, but it doesn't have the video writer and video capture function in the Android OpenCV, so we are able to deliver it to the app.
So, I might be lost here, but so the image is going to come down as an MFS, it comes into my Android app. Is your Android app taking over text messages to have your app as
So in the app, we have a button for user to click, and the user is able to go into their gallery and to specifically select the image they want to develop
So they
with.
save the image.
Yeah, you have
Yeah.
to save
Yes, and then never get in the gallery and open your app.
Yes.
So like the iPhone will pop up directly
Okay.
when we're using phone.
Did you guys have any thoughts about how you could improve that user experience and like how to make that more seamless?
Well, that wasn't the initial idea, because that's what ended up.
Gotcha.
Yeah, I would say for the future, because since we have the video developing working in the desktop, I would say maybe we can transfer it into a desktop application, so they will be faster to develop the video on the desktop. Yeah.
You have a microcontroller as well as a Raspberry Pi.
Yes.
The micro detects the event, sends it to the Pi takes the picture, and then it sends it back to the micro.
Yes.
Right.
Why do you have a micro and a Raspberry Pi?
Because the everything going external to the user's phone will go through the GPIS module on the microcontroller, and Raspberry Pi is just where we store the video and the picture.
Yeah, if you don't want a camera, it's okay for you still to defend your car.
Yeah, that's actually a customer requirement.
Yeah.
The camera module is optional.